Welcome to the Minesweeper Project on bbteacher.com. Our next routine will be to build the mine graphics of our mine cell control. So we'll move back into our code area, and we've just finished doing the button, and now we'll do the mine next. A good portion of the code is the same at the beginning, and so we'll copy the first few lines here, and let's add an end with to make it legal. And so what we have so far is we have the eGraphics with block, and we reset transform and then set our scale to the routine where it has the origin in the center and it has plus or minus 1 in each direction. Next, we'll clear the background, and the clear is not going to be with light gray for the mine, because the mine occurs after the button has been clicked. So we have to go with a lighter background, and we're using a color called white smoke. It's a slight off-white, and that's what we're using. Next, we need to set up a rectangle, and so we'll draw the next routine is to draw the circle in the center for the mine, and the circle in the center will require a rectangle, so we'll dim a C-rect as new rectangle F, and we'll supply the upper left corner and the width and the height, and those are the 4 arguments for a rectangle. We'll go negative 0.6, negative 0.6, and that's the top left corner, and then the width and height will be twice that value, the distance from there to the origin, which is 1.2 and 1.2. Now we'll also need to do a brush, so we'll dim a circle brush as new solid brush, and we'll use color black. Now we're ready with those 2 arguments, ready to go for the circle, and it's draw a fill ellipse, and we have to tell it the brush and the bounding rectangle, and this is the rectangle that just touches the circle on all sides, and that's C-rect. And it's time to do a test, so we'll do a rebuild. Take a peek at the form. We need to go back and set our property to the correct property to show the mine, and it's still set on button, so we'll set it down here on mine, and now we have that off-white, that white smoke background with our circle in front of it. Okay, next we need to do something about the little the pegs that stick out, the detonators on the mine, if you will, and so we'll call them pegs. That's a nice short word. And to do this one, we need a couple of radiuses, and so we'll dimension the inside radius as single equals 0.5, and we'll dimension the outside radius as single equals 0.8. If we need to change these later, it's really simple. We'll use the variables within the arguments. Okay, let's take a look at our model here. I've made a little mock-up of what we're trying to do on top of our black circle. And here's our model. We'd like to draw a line from an inner point to an outer point that comes from the center of the circle. If trig fans will recognize this is a unit circle with the outside circle having a radius of 1. The next circle has a radius of 0.8, and the next circle has a radius of 0.6. Now, if you've ever done this calculation before, you may remember that the distance over, if you drop down from a point, the distance from there to the center is the cosine of that angle, and the distance above the x-axis is the sine of that angle, and those actually are the x and the y coordinates. So you multiply the radius times the cosine and the sine to get the coordinates, and that's the trig. So let's look at what the 2 points would be. The inner point is 6/10 times the cosine of the angle. That's the x coordinate of the inner point, And 0.6 times the sine of the angle is the y-coordinate of the inner point. And a similar argument holds, except for the other point it's 8/10 from the center instead of 6/10. And these will give us the x and the y coordinates of the inner point and the outer point. Okay, now how do we code that? Well, we have to do a loop, and we have to do a loop that stops for each angle at 45-degree angles. And so we'll do a for angle as a single equals 0 degrees to 1 3/4 times pi, which we have to use the namespace math pi to get. And the step size on this, how far we jump on each loop through the loop here, is step 1/4 of, or 0.25 times math pi, or pi over 4, or 1/4 pi. Now what we have to do then inside here is to get the inside x and y and the outside x and y. And we can do this as a set of points. So dim inner point as new point f, and that will be the inside radius times the cosine math dot cosine of the angle, comma, and then the inside radius times math sine of the angle. And that will be the inner point. And the outer point will be almost identical. And the outer, ORAD, outer, as using the ORAD instead of the inside radius, you use the outside radius. And I think that's the only difference. So the inner point and the outer point may then be used. Now to draw the line we need to have a pen, because we're going to use a draw command, and draw commands use a pen, not a brush. So we'll do a dim, and we'll call this the peg brush as new brush, with a color of new as new solid brush, with a color of black, and a width of 0.15. And we'll have to convert that to a single. Doesn't like that. What's it looking for here? Oh, sorry. We need a pen. P pen. Can't give two arguments to a brush. This will be a pen, color black, and then it will take the 0.15 for its width. Okay, so now we're ready to draw. So now we have our pen ready to go, and our inner point and our outer point, and all we have to do then is for each of these 7 angles, we'll do a draw line from the inner point, using the brush or the pen, from the inner point to the outer point. And we'll have to test this now. So we'll rebuild and look at our form. And there we go. And we forgot one thing. That looks pretty good, except I'd like to have the ends of these lines rounded, and it turns out that's very easy to do. Back on our pen, we have to execute one more command, ppin, end cap equals, and then there's an end cap called round. And now we'll rebuild one more time and look at the form. And there's some nice round ends. Now we have one more thing, two more things to do, a little border around the outside and a little highlight. And for our highlight we need a rectangle. And this rectangle, we'll call this a draw highlight. And so we'll dim a rectangle. This will be the highlight rectangle as new rectangle F. And we'll need the upper left corner, and this is not too far from the center. We'll do a negative 0.3, negative 0.3, and a width and a height of 0.2, just as a guess. And we'll need a white pen, so dim, a white brush, dim WBR USH as new solid brush, color white. And now we can draw in our highlight, and so it'll be a fill rectangle using W brush HRect. And let's test that. And there's our little highlight. Okay, we need now a border around the outside of the cell. And the border can either be a set of lines or a simple rectangle. And so one more time we'll do a draw border. And it's almost like this last one, very, very similar. We can do two different rectangles. Do a rectangle here. This will be the border rectangle, B-rect, and it will go from -1, -1, and with a diameter of 2, with a width and a height of 2 and 2. And then we want to make this border in a, this will be a pin, so dim border pin as new pin, color gray, a width of 0.05, very slender, and fill rectangle with B-brush, B-rect, B-pin, and B-rect, and we have to do a draw rectangle. See if that works. And it doesn't like that. Can't do a rectangle F, but these are all integers anyway, so this should work. Okay, so now we're going to look for our little border, and so we'll rebuild one last time. And take a look at it. We'll click off of it, and there is a border, a light gray border around it. We have our white highlighting. We have our sticks or our pegs all the way around, and that looks like a completed mine. And that concludes this section, and thanks for programming along with us.